Welcome to Get Your FRQ On. This question is from 2011. It's question 5, and it is not calculator active. In the question stem, we are given a landfill being filled with solid waste, a function W, which represents the amount of solid waste, and a differential equation dW dt, which represents the rate at which solid waste is being added to the landfill, and that this model is expected to be good for 20 years. We are also given the initial condition that at time t equals 0, there were 1,400 tons of solid waste in the landfill. In part A, we are asked to use the tangent line at t equals 0 to approximate W of 1/4. Right, we are given that W of 0 is equal to 1,400. So, evaluating dW dt at 0, 400, we get 1/25 of 1,400 minus 300, which is 1/25 of 1,100, which is 44. So the slope of our tangent line at t equals 0 is 44. So if we write this in point slope form first, y minus 1,400 equals 44 times t minus 0. You can leave it in point slope form here. Since we're dealing with 0, a lot of people will just write it in slope-intercept form as y equals 44t plus 1,400. Doesn't really matter which one you use. It might be easier later if it's in slope-intercept form, but oftentimes point-slope form is just as easy for whatever you need it for. All right, so if we use this tangent line to approximate W of 1/4, we just plug in 1/4 in for t, and we get 11 plus 1,400, which is 1,411 tons. In part B, we are asked to find d squared W dt squared and determine if our estimate in part A is an overestimate or an underestimate. First, it's important to understand that d squared W dt squared is just the derivative of dW dt with respect to t again. So to find d squared W dt squared, we're just going to differentiate dW dt, which is 1/25 times W minus 300. Differentiating this, we get 1/25 of dW dt, which is just 1/25 times W minus 300 again. So 1/25 times 1/25 is 1/625 times W minus 300. All right, since W of 0 is equal to 1,400 and W is an increasing function, we know that dW dt will be greater than 0 for all t. Since 1/25 is positive and dW dt has to be positive, we know that d squared W dt squared is also going to be positive. So this implies that W of t is concave up for all values of t between 0 and 1/4. Well, if that is the case, if Wt is concave up, then our tangent line approximation should be an underestimate. In part C, if W of 0 is equal to 1,400, find the particular solution to the differential equation. All right, since we're given that W of 0 is equal to 1,400 and dW dt is 1/25 of W minus 300, we can separate the differential equation. And again, if it's separable, probably are expected to solve using separation of variables, so make sure that you do that. dW over W minus 300 is equal to dt over 25. Integrating both sides, we get the integral of dW over W minus 300 equals the integral of dt over 25, which gets us the natural log of the absolute value of W minus 300 equals t over 25 plus C1. Now that C1 is going to change, so I'm calling it C1. It's not my final constant, but don't forget to add the constant when you're done integrating. All right, so if we simplify this, exponentiating both sides, we get the absolute value of W minus 300 equals e to the t over 25 plus C1, which means that the absolute value of W minus 300 is e to some constant times e to the t over 25. And at this point, we technically don't know whether or not we need a positive version for this function or a negative version of this function. It's pretty easy to conclude which one we need, but if we're just simplifying, oftentimes we're going to let k equal either the positive version of e to the c1 or the negative version of e to the c1. And since we haven't really determined yet which one it is, we don't really need to at this step either. So we can rewrite this as w equals 300 plus k e to the t over 25. All right, since w of 0 equals 1400, I can plug those values in and figure out what k is. All right, well, 1400 has to equal 300 plus k times e to the 0, which implies that k is equal to 1100. And if I have 1100, that's really the only parameter for this solution that I needed to find yet. So the particular solution is y equals 300 plus 1100 times e to the t over 25. And again, this is only expected to be good on the interval from 0 to 20. That is from the question stem. You should include that. It may cost you a point, or you may fail to earn a point if you don't specify the restricted domain, which was given in the question stem. You may be expected to refer back to that information later.